Hello, my name is N. Kishore from Artificial Intelligence and Data Science Department, studying in Johnson Institute of Technology, first year. Now let us get into the topic of generation of power alcohol from aquatic macrophyte as a non-conventional energy source, a case study. Introduction. India is the fifth largest primary energy consumer and fourth largest petroleum consumer in the world. Growing population and rapid socio-economic development has supported an increase in energy consumption across all major sectors of Indian economy. Given limited domestic energy resources, most energy requirements are met through imports. Provisional estimates indicate that India meets more than 76% of its petroleum demand through imports. Import expenditures on petrol products is official 2009-10 is over $83 billion, up 4 times the value in official 2003 to 4. Sequentially, petroleum consumption has also gone up. Problem analysis. Macrophytes as an unconventional energy source. Bioethanol is being considered as a potential liquid fuel due to the limited amount of natural resources. Cellulose biomass is also being investigated as a potential substrate for bioethanol production. The water hyacinth is a native plant of Brazil but has neutralized in many tropical or temperate countries. It is regarded as the nuisance because of its remarkable growth rate. Although the water hyacinth is considered by many as invasive pest, it could be useful as a source of biomass because it is abundant and easy to cultivate. Previous studies have addressed the potential use of the water hyacinth as biomass or as a way to improve water quality because of its capacity to absorb heavy metal and organic compound. These studies indicate that water hyacinth is a promising plant for ethanol production. Problem solution. Extraction of ethanol from water hyacinth. Photosynthetic process in plants produce simple and complex sugars which can be decomposed by fermentation in the presence of microorganisms such as Escherichia coli and Calebicilia oxytoca. Saccharomyces cerevisiae and Zomomonas mobilis to produce bioethanol. It is highly soluble in water and hygroscopic, thus requiring an energy intensive distillation process to separate it from the mixture during the extraction process. 6CO2 plus 6H2O plus solar energy gives C6H2O 12O6 plus 6O2. Photosynthetic glucose or simple sugar. C6H12O6 gives 2C2H5OH which is ethanol plus 2CO2 plus energy glucose. Methodology adopted for ethanol production. The potential benefits of fuel ethanol have been long understood. However, it is the development of new biotechnologies that are the beginning to make this option a technical and economically viable option in large parts of the world. There are 4 biomass feedstocks, each with requires a somewhat different technology. Monomeric sugars. Traditional fermentation can directly convert the simple sugar such as those from the sugar cane and the sugar beets into alcohol. This is the primary method that has been used to produce alcohol for human consumption for thousands of years. However, the availability of these feedstocks is limited because they are used for food. Today, most of the fuel ethanol from simple sugars is made of sugarcane in Brazil, where the combination of land, labor, and climate provides favorable economic conditions. Starch. Starch is a biopolymer of glucose, a monomeric sugar. It is the primary component of the corn and other grains. Starch cannot be directly fermented into alcohol an enzyme is required to break it into simple sugars. The simple sugar can then be fermented into alcohol, while brewers learned long ago how to use natural enzymes to achieve these convention. Only in the last several decades has modern industrial enzyme technologies developed methods to make inexpensive enzyme to allow economic production of fuel alcohol. Cellulose. Cellulose is the most common form of biomass and is also a biopolar of glucose. It is structured to be difficult to break down and thus serves as a defense mechanism for plant because only some animals can digest cellulose. Hemicellulose is the fourth of sugar biopolar. However, unlike the other sugar, it is the highly branched chain of 5 or 6 carbon sugar. It is the second most common form of biomass. Like cellulose, only some animals have the capability to digest it. Conclusion. From the above studies, the following concluding remark appears to be justified, that as a noxious weed, water hyacinth has, be, has to be utilized as a mass for production of energy in form of biomass ethanol. Instead of eradication, the byproducts obtained during the production of biogas or ethanol could be easily digested, produces a good fibrous fertilizer with high NPK content, and which alternatively increases the aeration capacity of the soil and ultimately yield a crop. A low cost project could be set up in rural areas so that it could provide job potential and local people and energy source with least cost. This could enhance the social and economical growth of the region, thereby reducing the spread of the noxious weed like the water hyacinth. Thank you.